Good day, stats enthusiasts. Welcome to this AI-assisted learning session. Today, we're diving into a super powerful and super flexible stats tool called Bootstrapping. Click Compute, conclude with confidence, Bootstrapping in JASP for teachers and students. Okay, quick question for everyone. Have you ever tried to study while also doing the dishes, taking care of your younger siblings, or helping out in your community? Flipping through your notes while cooking rice or watching your baby cousin? And somewhere in the middle of all that, you wonder, is all this studying really going to pay off? Well, that's everyday life for many AGTA youth in San Guillermo, Isabela. They're a part of the Alternative Learning System, ALS, but they're not just students. They're family helpers, culture bearers, hardworking members of their community, all while trying to learn and grow academically. Now, here's the exciting part. A group of researchers from NU, North Luzon, teamed up with AGTA community leaders and the IP representative officer to explore a question that really matters. For AGTA learners who are juggling school and life, does spending more time studying lead to better test scores? That's what we're going to explore today. And not just by talking about it, we'll use real statistical tools to dig into the data just like the researchers did. Ready to explore? But before we dive in, here's what you'll walk away with today. By the end of this session, you will be able to explain the concept and appropriate applications of bootstrapping, apply and interpret bootstrapping analysis using JASP. In this session, we will be using a statistical tool called JASP. JASP is a free open source statistics software that makes data analysis easy and intuitive. Now, before we jump into the analysis, let's get one thing clear. What exactly is bootstrapping? Nope, we're not talking about actual boots or pulling yourself up by your shoelaces. In stats, bootstrapping is a clever way to resample your data. Basically, you take your original data set and randomly draw samples from it over and over again. But here's the twist. You put the data back each time before drawing the next one. It's like picking names out of a hat, then tossing the name back in for the next pick. Why do this? Because sometimes the math behind figuring out how a statistic behaves is super complicated or just unknown. Bootstrapping lets us estimate things like the standard error, confidence intervals, and even p-values, all by just using the data we already have. The best part? It doesn't need huge amounts of data or assumptions that your data follows a perfect pattern like a bell curve. That makes it a lifesaver when you're working with small samples or data that's all over the place. Plus, it's especially handy when analyzing stats like the median, where traditional methods can trip up. So, bootstrapping is kind of like your stats Swiss Army knife. Flexible, powerful, and ready to work even when the data situation isn't ideal. Cool, right? Let's see how it works in practice. All right, let's go back to our big question. For AGTA learners who are juggling school and life, does spending more time studying actually lead to better test scores? Who thinks study time definitely makes a difference? And who thinks maybe not always? Great! To answer this question like researchers, our first step is to set up our hypotheses. For null hypothesis, and feel free to say it with me if you know it, there is no relationship between study hours and test scores among AGTA learners. That means even if some students study more, it doesn't really impact their performance. If we see differences in scores, it might just be luck or other things going on in their lives. For alternative hypothesis, there is a relationship between study hours and test scores. In other words, if students spend more time studying, we expect to see better test results. Now that we've stated our hypotheses, don't worry, it's not going to be complicated. With the help of JASP, analyzing this will be fun and fast. Here are the raw data collected from 30 participants. So grab your laptop, open up JASP, and fasten your seatbelt. We're about to dive into bootstrapped correlation analysis. Step 1, load your dataset. Make sure your file is open and that both variables, study hours and test scores, are in numeric format. Ready? Great. Step 2, to get those descriptives. Click on the Descriptives tab at the top. This is where we check the story behind our data before diving into correlations. Now, move study hours and test scores into the Variables box on the left panel. Easy, right? Under the Statistics panel, make sure these are checked. Mean, standard deviation, minimum and maximum, median, optional but helpful, and number of valid responses. Got that? Awesome. A descriptive analysis showed that students had a mean exam score of 69.50, SD equals 6.62, with scores ranging from 57 to 84. The mode was 67 and the median was 69, suggesting a fairly symmetrical distribution, so overall no extreme outliers. Most students are hanging around the same performance level. So what does this all mean? While many students didn't study that much, the average score was still pretty decent. But if we dig deeper, maybe those who studied more got higher scores. That's something we could explore in a correlation next. Awesome! Now that we've explored the descriptive stats of study hours and test scores, let's move on and test if there's a real relationship between them. First, go to the top menu, click on regression, and then choose correlation. But before we dive into results, let's check for normality, an important step that tells us which correlation method to use. Click the assumption checks box, then check Shapiro pairwise normality. Take a look at the results. The Shapiro-Wilks statistic is 0.985. The p-value is 0.987. Since our p-value is way above 0.05, that tells us our data is normally distributed, so we're good to go with Pearson's R. Next, make sure the following are selected. Pearson, if data is normal, confidence interval set to 95%, then turn on Bootstrap and set B equals 1,000. This means JASP will generate 1,000 resamples to help us get a more reliable estimate of the correlation. So now we're ready to see, is there really a connection between how much students study and how well they score? Let's take a look at those results next. A bootstrapped Pearson's correlation analysis was conducted to examine the relationship between study hours and test scores based on a localized assessment. And the null hypothesis stated that there is no relationship between study hours and test scores, while the alternative hypothesis suggested that a significant relationship exists. The results revealed a very strong positive correlation, R equals 975, with a bootstrapped p-value less than 0.001, which is below the conventional alpha level of 0.05.
The 95% confidence interval for the correlation ranged from 0.954 to 0.988, based on 1,000 bootstrap replicates. The lower bound, 0.954, and upper bound, 0.988, indicate that we can be 95% confident that the true population correlation lies between these two values.
Therefore, the result is statistically significant, indicating that the observed relationship is unlikely to be due to random chance. As such, the null hypothesis is rejected in favor of the alternative hypothesis. These findings suggest that increased study time is strongly related to higher test scores among the AgTA participants. All right, we've crunched the numbers, bootstrapped our correlation, and now it's time to ask, what does all this actually mean for students, teachers, and real classrooms? First, a quick recap. We used Pearson's correlation with bootstrapping because our data passed the normality test and we wanted more robust, reliable results, especially since we're working with a small sample of Indigenous youth in the ALS program. Now for the exciting part. Our results showed a very strong positive correlation, R equals 0.975, and the bootstrap p-value just 0.001. That's highly significant. This relationship is definitely not happening by random chance. So let me ask you, if students study more, what tends to happen to their scores? Exactly. What this means in real life? From an educational point of view, this tells us something powerful. More study time equals better academic performance. And for learners like the ACTA youth who juggle school with community duties, this shows the value of structured, supported study time. This analysis didn't just give us a number, it gave us accurate evidence we can use. It shows that when we invest in our students' learning time, we invest in their success. So let's remember, the effort they put in and the support we give really does make a measurable difference. I would like to thank the following AI tools for making this micro-teaching session possible: JASP software, Canva, Adobe Express, 11 Labs, Microsoft Copilot, ChatGPT, and a screen recorder. These tools supported the design, analysis, voice generation, and overall delivery of this AI-assisted learning experience. Until next time, in another exciting episode of parametric and non-parametric testing, dear stats enthusiasts.